Airplane turbines, also known as jet engines, are the primary propulsion systems used in most modern aircraft. They work on the principle of the Brayton cycle, which involves compressing air, mixing it with fuel, combusting the mixture, and then expanding the resulting gases to produce thrust. Here's how an airplane turbine works. Air intake. The process begins with the intake of large amounts of air from the atmosphere. This air is drawn into the engine's inlet, typically located at the front of the engine nacelle housing. Compression. Once inside the engine, the air passes through a series of rotating compressor blades. These blades compress the air, increasing its pressure and temperature. The compression process significantly raises the energy content of the air. Fuel injection. At the exit of the compressor, fuel is injected into the compressed air. The fuel is typically a hydrocarbon-based liquid, such as aviation kerosene, Jet A or Jet A1. The fuel mixes with the compressed air to form a highly combustible mixture. Combustion. The mixture of compressed air and fuel enters the combustion chamber, where it is ignited by a spark plug or similar ignition system. The combustion process rapidly releases heat energy, causing the temperature and pressure of the gases to increase further. Expansion. The hot, high-pressure gases produced by combustion are expelled through a series of turbine blades. These blades are mounted on a shaft which is connected to the compressor blades at the front of the engine. As the hot gases flow over the turbine blades, they expand and lose energy, causing the turbine blades to rotate. Thrust generation. The rotation of the turbine blades drives the compressor, which maintains the airflow and compression process. Additionally, the energy extracted by the turbine blades is used to turn the engine's fan or propelling nozzle, generating forward thrust. Exhaust. After passing through the turbine, the now expanded gases exit the engine through the exhaust nozzle at the rear. The high-speed exhaust flow creates a reactive force known as thrust, which propels the aircraft forward according to Newton's third law of motion. This continuous cycle of intake, compression, combustion, expansion, and exhaust enables the airplane turbine to produce the thrust necessary to propel the aircraft through the air at high speeds. Different types of turbine engines, such as turbojets, turbofans, and turboprops, vary in their specific designs and applications, but generally operate on similar principles.